So let's look at ketones. Ketones have a C double bond O with a carbon on both sides. This is also known as a carbonyl group, the same as for the aldehyde group. What we're really focusing on in that case is the C double bond O. There is a distinct difference in the reactivity of aldehydes and ketones, so it's important to tell the difference. We have a general formula for ketones that has R, which again stands for hydrocarbon chain, C double bond O, and then R prime, which again stands for a hydrocarbon chain that may or may not be the same as the one on the other side. The condensed structural formula is RCOR prime. In this case, remember that the C double bond O is not easily observed, but if you count the number of bonds that should be on the carbon, you'll find that you need to have a double bond to that oxygen. Much later in this series of talks, we'll be talking about the physical properties of ketones. I will not be talking about it now. What we're going to work on next is the naming of ketones. The basics of naming ketones is going to start with the end. We're going to put ONE for the ending for ketone. Then we're going to put AN in front of that to indicate that it's an alkane for the rest of the bonds. If there were double bonds or triple bonds, we would change that to ene or ine. Then we're going to find the longest continuous carbon chain that includes the carbon of the carbonyl group. Our next step is to number the carbonyl carbon, giving it the lowest possible number. And finally, we'll add in any substituent groups and use the numbering system that we decided on with the carbonyl carbon. Let's try a few examples. Compound A. The first step is to identify the functional group. Here we see a C double bond O, and we see that there's a carbon on both sides, so we identify it as a ketone. The ending on the name will be ONE. Then we notice that all of the other bonds have carbon-carbon single bonds, and so that will be AN. In front of that, we're going to say how long the carbon chain is that includes the carbon that goes through the carbonyl carbon. In this case, we have 3 carbons, so that is prop. So we currently have propanone. Next, we want to indicate the carbon number where the carbonyl carbon is. In this case, that's going to be carbon number 2. It doesn't matter which direction I count it in, it will be number 2. So the name would be 2-propanone. But do we need that number? Well, no, we don't in this case, because if I put it on a different carbon, it is no longer a propanone, it becomes a propanal. Since there is no such thing as one propanone, we know that there is only one compound, so it is just propanone. Now let's look at compound B. Here again we see that it's a ketone, so we're going to put in -one at the end. We see everything else is single bonded, so we put AN in front of that. We look for the longest carbon chain that includes the carbonyl carbon. In this case, that's 4 carbons long, so we have butanone. Now we put in the number, and counting in the forward direction, it's on number 2. In the reverse direction, it's on number 3. We would choose number 2. So this says that it's 2-butanone. Do I need the number 2? Let's think about it. Move the carbonyl carbon over 1 to the left, and it becomes an aldehyde. So that means I don't need another number. Now let's move it to the other side of that carbon, and we would see that it is now on number 3 in the forward direction, or number 2 in the reverse direction. So we'll go ahead and count the reverse direction. We'll get the same answer as we originally had. That means we have not found another substance. And finally, we'll put one on the other end, and that's going to match the same as number 1 and as an aldehyde. So we do not need a number in this case. It can only be on position 2. So the answer is butanone. Now let's focus on compound C. Again, we see the C double bond O with carbon on both sides, so it's our carbonyl carbon. And this is a ketone because it has a carbon on each side. The ending will be -one. Then we look to see if there are any double bonds or triple bonds, and we see it as all single bonds between the carbons. So we put in AN. And in front of that, we're going to put in the number of carbons that are present in the chain, and we see we will have a pentanone. We put a number in to indicate where the carbonyl carbon is, and it will be on number 2. So this is 2-pentanone. And then we're going to put on the substituents. Here we see 1 carbon. That is going to be methyl, so we're going to have methyl-2-pentanone. And finally, we need to give a number for that substituent, that methyl group, which we see is on position 4, because we are following the numbering decided by the ketone. we see that we have 4-methyl-2-pentanone. We are required to have the number for both parts of this. Now let's look at compound D. Here we see we have a carbonyl carbon. It is a ketone because there's a carbon on both sides, so the ending is -one. We look at the rest of the carbons. They are all carbon-carbon single bonds, and so we're going to say it's an AN, so we have -anone. Now we look for the longest continuous carbon chain. That includes the carbonyl carbon, and we see in this case that there are 6 carbons, and that is hex, so we now have hexanone. Now we need to tell what number the carbonyl carbon is on, and counting in the forward direction, we get number 4. In the reverse direction, we get number 3. That means that we'll be using 3-hexanone for our name. Finally, do we need to have that number in there? Well, if we test it by moving it over 1 carbon to the left, it's still 3-hexanone. So that would say we don't need a number. But if we continue either moving it 1 more carbon to the left or 1 carbon to the right, you end up with 2-hexanone. That is another number, and so we end up, yes, we do need to have the number. The compound here is 3-hexanone. Now, let's try drawing a few ketones. So we'll start drawing ketone structures from given names. Let's start with compound A, 3-propyl-2-hexanone. We look at the last part first. We see it's ONE, tells us that we have a ketone. We put the AN in front of it, and that tells us that it must have all carbon-carbon single bonds for the rest of the structure. And then we see the hex, and that tells us that there are 6 carbons in the main chain. We'll go ahead and draw those 6 carbons. We'll add our ketone to carbon number 2, as indicated by this number. So we now have our 2-hexanone. Now we just have to add in our propyl substituent, and that is going to go on to carbon number 3. And that is the carbon skeleton. Next we need to add in all of our hydrogens, so we make sure that every carbon has 4 bonds and every oxygen has 2. And that is our 3-propyl-2-hexanone. One thing to notice about this compound in particular is that there is a longer hydrocarbon chain. We could have had a heptane, but we had to make sure that the main chain went through the carbonyl carbon. And in order to do that, we had to have a shorter main chain, the hexanone we see here. Now let's look at this very busy one, letter B. We will see 5,5,7-tribromo-6,6-dichloro-4-ethyl-3,3-dimethyl-2-heptanone. As you can see, there's a lot of stuff here, but we still start in the same way. We look at the tail end, and we find our functional group. We see that it says -one, which means we're going to have a C-double bond O with carbon on both sides of it because it indicates a ketone. In front of that, we see the AN, which means all of the other carbons in the chain will be single bonded. And in front of that, we see hept. The hept is important because that is our main chain. So we'll draw out our 7 carbons. Now we need to make sure that we put in our ketone. That is one of the most important steps because once we put that in, we've decided the direction for counting. So go ahead and put in your ketone on the 2nd carbon to make our heptanone. Once I've placed my ketone, now there are different ways that people do the problem. I personally like to start from the start and work all the way across and put in all of the things. So I'm going to read number 5, and I'm going to say, okay, what goes on 5? Oh, a bromo. Put a bromo on number 5. And then on number 5 again, we're going to put in another bromo. And then we go to number 7, we put in another bromo. Then we go to carbon 6, we add a chlorine, and 6 again, we go to chlorine again. And then number 4, we're going to add on an ethyl group, and ethyl is 2 carbons long. And then we go to carbon 3, we're going to put on 1 carbon chain, methyl, and another 1 carbon chain for the other methyl. Now we've got all of our carbon structure done. This is our carbon skeleton. And our last step is to add in our hydrogens. Make sure that every carbon gets 4 bonds total, every oxygen has 2 bonds total, and all of the halogens and hydrogens have only 1 bond. And there's our structure. We have our 5,5,7 tribromo 6,6-dichloro-4-ethyl-3,3-dimethyl-2-heptanone. So as you can see, you can do very busy structures just methodically going through the name. You will not be given anything this challenging on either the homework or your exams.